we are actually going to recap quite a lot of stuff, as you can see from this particular lesson slot over here. But most importantly is this. We are actually going to see how we apply matrices in real-world context. So how does it apply? Okay, in fact, let's recap a lot of stuff first, shall we? Okay, so as we know, what is a matrix? A matrix we can represent as a rectangular array of numbers. And in this case, the numbers inside are known as elements. Okay, so what is the order of the matrix over here? Order of the matrix, if you recall, it's number of rows by number of columns. Remember, we don't multiply them. In this case, the order over here, if you all realize, 2 rows, 3 columns, it's going to be 2 by 3. Do not write 6, write 2 by 3. Very important over here. Okay, next up, okay, more recap. Equal matrices. When we say two matrices are equal over here. Okay, one thing to take note, firstly, we say they are the same order. And nextly, all the corresponding elements are equal. Okay, what does this mean over here? I'm just going to color code. If two of the elements are equal, their corresponding positions, and they will be equal. Henceforth, A will be equals to W, B will be equals to X, C will be equals to Y, and D will be equals to Z. If you follow the color coding, the equations will follow from there. Alright, okay, following up even more, I hope this is more clear. A lot of recaps over here. Okay, you can try to catch up over here because it's a lot of to answer Denise's questions. You can actually, that's why we are doing all the recap over here. So if any questions with regards to the basics, just ask ahead over here because I do not really recommend to just to catch up for this specific lesson for proper. All right, Denise? If you have any questions with regards to the basics down, just ask ahead over here. All right? Okay, because I don't wish to waste too much time over here. Yes, okay. So two matrices, take note, if I want to add or subtract them, they have to be in the same order. Okay, same order, same size. So therefore, if A and B are as such, I can add them accordingly as A plus W, B plus X, C plus Y, D plus Z. Or in this case, A minus B, it's going to be subtracting each of the elements. Okay, so if I add, I add. If I subtract, I subtract. But take note, I only do that at their corresponding positions. So I cannot do, let's say, example, A minus Z, A minus X. No. If it's at the first row, first column, I subtract it relatively at the first row, first column. If I add them accordingly as well. So just take note from there. Alright, so there's adding and subtracting as well. And this is actually the first lesson. If we scalar multiply, when we do it, we say each element. If we scalar multiply each element over here, it's multiplied by k. So that means if I have k of A, each particular element is going to get multiplied by k. Okay, each of the numbers is going to get multiplied by k. Very straightforward over here. Now, next one over here, matrix multiplication. Let's recap. We can only multiply the two matrices together. This is where I will ask all of you, do you recall what the condition here is? The number of what in my first matrix is equals to the number of what in my second matrix. Does anybody recall the two words in their exact positions? Should be. So let's face this word first. The number of what in my first matrix. What is that word I'm looking for? I'll give you some time to think about it. What is that particular word I'm looking for? Very good. Very good, Denise. That's actually correct. Jena Vivi, that's actually not correct over there. I'm not looking for the elements in the first matrix. Elements, you realize, is in the previous part. But Denise, you've gotten it correct over here. Maybe let me bring it down to the floor to give it a shot for the rest. What is the particular words I'm looking for? Yeah, I'll give you some time, don't worry about it. In fact, Denise has gotten the answer, and these are the exact words I'm looking for, so I'm gonna actually show her comments to all of you all. Okay, we're actually looking at the two words at the corresponding positions over here. Good job, Denise. In this case, the number of columns is equals to the number of rows. Okay, so why? So how does that work over here? If the order of the matrix A is m times n, whereby n over here is the column of my first matrix, and the second matrix n over here is the row, then the order of my matrix A, B is going to be m times b. And if you recall last week's lesson, if I multiply two matrices, if I switch their alphabets, they are not the same. If you forgot it, you can refer to last week's Genie class and it will all be enforced from there. Alright, so just take note over here. And lastly, what happens is, we know the condition of matrix multiplication. But how do we actually multiply them? All right, okay, this will be the last recap. Okay, in fact, matrix multiplication is the most important over here when we talk about multiplying them. Okay, so now when we multiply them, okay, let me write down the matrices for you. When we multiply them, so it will be like this: A, B, C, D, W, X, Y, Z. In fact, the most important part of matrix over here for today's lesson is the matrix multiplication part. Okay, so let's take a look. What will be, okay, let's test everyone here. What will be the answer for the element for AB? What is the particular equation I'm looking for? Give it a try. I'll give you some time to think about it. What is the particular equation I'm looking for? Or expression, not equation, sorry. Expression over here I'm looking for when I take the multiplication of these two. I'll give you some time to think about it. Okay, remember this is the first row, first column, so I'm actually multiplying the first row of the first matrix multiplied by the second row of the first column of the second matrix. Almost there, Jenna VV. Is that one of the elements is not correct? A, W, and then Y. What is an alphabet that is missing there? Yep, that is right, Jenna VV. That's actually correct. For the rest, everyone here, anybody wants to give it a shot? Okay, now I believe most of you all got it over here. AW is one, but take note when I multiply matrix is this one and this one. You still need to do one more particular part. Remember, top to top, and then the bottom to bottom. All right, so that's one thing to take note. So it's actually AW plus B of Y. Okay, let's give it another shot to make sure that everyone's understand this over here. Let's say I want to multiply the yellow part to the, sorry for that, the red color part over here. X and Z. A, B, X, Z. What will I get over here? I'll just let you all try one more time to make sure that everyone gets it down. Yeah, I'll give it wait a while to make sure that everyone gets it down. All right, very good, Jenna VV. That is actually correct. Denise is actually correct as well. You guys got it out. Very good. Okay, is that AX plus BZ? But I think you guys got it down already. So following up, if let's say I have the green color rows, this is not green, sorry for that, green color row, and then multiply with the blue column. This is going to give me CW plus DY because second row, first column. Following up one more, I have CX plus DZ. Okay, this is the notion of matrix multiplication. Yeah, that's right, Jenna VV, and following up from the last one to give it a shot. Right, so hopefully you guys are doing good in terms of following all the possible recaps, which we will focus for today's lesson, application of real life in matrices. So before we go there, let's go through a mathematical concept with an example. Okay, now look at this question very carefully. So bakery sells donuts and cupcakes in small and large boxes. Cost of a small box costs 16, cost of a large box it's $18. Okay, I know the price is a little bit weird, but ignore that fact first. For both donuts and cupcakes, so regardless whether donuts and cupcakes, small box of donuts is 16, small box of cupcakes is also 16, and big box as well. Okay, that's what it meant. Okay, now the table over here shows the number of items on a particular day. So realize what happens. Sometimes this table is correct, but sometimes the table gets too very big. And there are a lot of these alphabets here that I don't really want to consider when I'm doing our calculations. So I actually want to simplify to something. Now I realize the numbers over here are very, very familiar, are in fact other numbers over here as well, if I write it in the form of a matrix. So if I look at this particular matrix very, very closely, what do the elements of A actually represent? Anybody who's supposed to give it a shot. Now, what do the elements of A actually represent over here? In fact, if this is a little bit too hard for you to type, maybe let me zoom in over here. If you understand the question, what does this particular element represent based on the question? If you sometimes think about it, okay, this is actually the journey of process of understanding how matrices work. And if I will help you all a lot, okay, we all give you some time to actually think about it. Get a bit more. If you look at number 9 over here, I think I see some good responses over here. Very nice. Look at number 9 over here. What does this tell us? This tells us that the number of 9 small boxes of donuts are sold on a particular day. Very nice. 9 small boxes are sold and it costs $16 each. Yeah. The $16 is a little bit extra over here, so we don't really say that. I only want to know what's the 9. The 9 small boxes over here sold on that particular day, which I think you got it. Okay, so the $16 each is not considered here first because I'm only considering the number 9 first. What does the number 9 represent over here? In fact, let me just write it down. The number 9 over here represents the number of, in this case, small boxes of donuts sold on a particular day. Here's the notion over there. That is what it means. The number of small boxes sold on a particular day. And if you repeat for each of elements, this is what we represent. And it is actually much cleaner because we don't have all these alphabets over here that does not represent. In fact, you realize with matrices and matrix multiplication, all these calculations can come into play. Now, then you may wonder, as what Denise mentioned, the $16 is actually going to help us perform certain calculations. Okay, is can anybody hear me? Do you actually want to refresh accordingly as well? Okay, my voice is breaking up. Okay, let me just do a little while. Okay, let me just do a little bit of motion over here. Give me a moment. Give me a short while. Okay, is this a little bit better now? How about now? Is it a little bit better? I hope it's a little bit better now. Yeah, okay, okay, yes, okay. Glad to hear that. Now let's follow up nicely. Now let's go on to bubble question 1, shall we? Okay, so instead of following the, just now you realize it's actually the same question. 9, 5, 7, and 4. But right now, I actually want to write it in the form of a column matrix for this price. How do I write it? Okay, let's initiate the feedback. Launching the bubble launcher in 3, 2, 1, and let's go. Okay, it's only 30 seconds, so give it a shot. Let's see how we do it accordingly, all right? Right, that's good. I'm getting the nice response here. Moving now to the rest, let's see how you guys do it, all right? Look at the question carefully. You have about 15 seconds left. Take note, I'm looking at a column matrix. Don't fall into the trap. Last 10 seconds. Have those buttons clicked. Last 5. Okay, I think some of you all just try to randomly click. Okay, let's see. So if you realize, okay, I would say there's a little bit of a confusion here. So let's see. Small box, what is the price? The price is $16. Right? $16. Small box, the price is $16. Large box, the price is $18. So if I were as a column we call it is written downwards. So therefore my matrix will be like this manner. And you realize these two choices are actually out. Make sense over here? Now if we then follow up nicely, Small box, large box, how will I write it as a column? Some of you are actually written 4, but it's not really 4 because take note, I'm looking at the price. 8 and 9, are they the prices of the matrix here? No, so therefore we actually don't simplify. We write the prices as it is. And henceforth it's going to be just 16 and 18, henceforth number 3. Alright, I hope you all got the understanding. So I'm going to launch the feedback to see whether you guys actually do got the response. So just click on. Okay, so this is actually a new thing over here to actually see whether you guys understand or roughly understand. So just click it down to actually see whether you guys do actually understand what I'm trying to say. Okay, if not, I can always do my explanation again to actually sort of make it understand them better. Okay, so seems like there's a little bit of, okay, halfway understanding. Okay, so let me reinforce a little bit more. Okay, why is it not number 1, Jenna? V? Okay, take note. I want, look at the question. What does the question say? Column matrix. Is this a column matrix over here? That's a row. So that's why 1 is not accepted. Take note. Look at the question. Question says column. We give it a column. And then we don't simplify because we just want the prices. All right, we just want the prices of the matrix. So it's going to be 16 and 18 over here. Because the prices literally states it's going to be actually 16 and 18. All right, so just take note. We don't simplify because we just want to write down what it is given in the question and not change it. Okay, I do hope this is a little bit better in terms of explaining now. And let's see how we can follow up with the work example over here. So right now you realize part A is actually done in the previous bubble question, which is 16 and 18. Now, calculate AB. Let's see first. AB is actually your matrix multiplication. So let's try 9, 5, 7, 4. And in this case over here, 16, 18. Now let's recap. Can we do our matrix multiplication? 2 times 2, 2 times 1. So can we do our matrix multiplication over here? Yes, we can. Number of columns of the first matrix is equals to number of rows in the second matrix. So we multiply them, and you realize it's just 9 times 5. Let me just write it out. 9 times 16, sorry, not 9 times 5, plus 5 times 18. 7 times 16 plus 4 times 18. Now, what is this going to give? This is going to give 2, 3, 4, and 1, 8, 4. Now, part C is actually whether we are understanding what we have been doing so far. So, when we matrix multiply and give us 2, 3, 4 and 1, 8, 4 respectively, what is actually happening? What does AB represent? Now, if I look back at the table of what we have, this one represents the number of boxes that are sold. Okay, and the other one actually represents the prices. And then if you take a look at it specifically, if I would look at it row-wise, if you would recall, this row over here, if you were to look up, actually represents the, let me just recap, I can't remember as well. I think it's donuts. Yes, it's donuts. I might have spelled donuts wrongly. Donuts over here. And the other row actually represents my cupcakes. So if I multiply AB, what do I actually get? I take the number of boxes sold times the prices. You realize what I've been getting? Look at this entry closely, and it will be clearer. Okay? This actually tells me what? This one is the small box of donuts sold. And in fact, Jude has given me the correct answer. Yes, but you have to add actually one word over there. It's not really the total number of sales, but in fact, I will just edit your word a little bit because I'm talking about money over here. Because it's a small box of donuts. Okay, you're almost there, Jude. You're almost there. Hang in there. Okay, you're almost there. The first one represents the small box of donuts sold. And the other one is what? The other one is actually the price of the donuts. And if I were to take a look at it, the other one is going to represent the small box of, in this case, cupcakes. So this is going to be my cupcakes. Okay, small box. Okay, there's a lot of words there, so just bear with me. Cupcakes. So, and this one over here is going to be the price of my cupcakes or donuts. Okay, let me just refer to the table. I'm also a little bit confused. Small, large, donuts. Yes, donuts. Donuts. Yes, donuts. Sorry for that. Price of a small donut and price of a big donut. Right? Okay. Let me just rewrite this. Price of a small donut and price of a big donut. So big donut. Okay, and then this is small. So realize when I add this all up, what do I get? It's actually, to rephrase Jude's phrasing, it's actually, what does AB represent? AB actually represents the total revenue from selling donuts and cupcakes respectively. So one column is the donut column. The other entry is actually, the other element is actually a cupcakes element. Right, so this is a little bit confusing. So I want to get your feedback to actually see whether you understand this part first. Okay, if you don't understand, don't worry about it. I'll be more than happy to actually reinforce any part that is a little bit alright. Okay, I'll just monitor the feedback first. Okay, I'll just give it a while more for the responses to come. Okay, seems like most of the responses are towards the other side, so that's a good sign. Okay, for the one that has the red one, if after the lesson, if it's still unclear, just let me know. I'll be more than happy to answer your query. Alright, don't worry about it. Okay, I think the responses is alright, so let me just go on. But for the one who has been appearing on the red side, just let me know, or in this case, yeah, on my red side, which is actually the one you totally don't understand, just let me know. Okay, I'll be more than happy to answer your query during the Q&A. Alright, most important. Okay, next up. Bubble question. Let's see whether you understand. So what we want to form a suitable matrix. Now, this one, they never tell you whether it's column or row. You actually have to form it, and then we see how we can actually simplify the price of each of the matrix. And then find AB. Take note, I want to find AB. Ultimately, take note, I am finding AB over here. So the hardest part is actually to form a suitable matrix first, and then I find AB. All right. I'll give you some time to think about it. 1 minute might be a bit too short, so I'll give you some time to actually figure out before I launch the bubble launcher. So you all can start first. I'll actually launch the bubble launcher in 30 seconds. All right, 30 seconds. So take note. What is the matrix that I need to put in here to actually sort of give my answer as such? So which one is it? Okay, I'm going to launch it in the next 5 seconds. 5, 4, 3, 2, 1. Let's go. Let's see whether you all can get it. Okay, this is going to be a little bit hard over here. Okay, take note the information. Whenever it comes to real world context, the information here is very, very important. Very important over here. Okay, there's last 30 seconds and I don't see anyone's response yet, so quick, write it out. Or is it the time it might be a bit too short for you all? Okay, last 18 seconds. All right, I have a first good response over here. Okay, I think the timing is a little bit too rushed. Wow, that's good, that's good. I have good responses over here. Last 5. Alright, okay, seems I have most of our responses down over here. That's a good thing to hear. That's a good thing to see. Good thing to see. Alright, so what happens? I believe most of y'all from the answer that you know our matrix in order to get has to be able to be multiplied. So you realize the answers over here is quite straightforward. Firstly, I know there's a 2 by 3 based on the options over here. I have a 2 by 3, so 2 by 3. 2 rows, 3 columns down. So 2 by 3, and then the matrix I need to multiply is, in this case, over here. It has to be a 3 by 1 because you realize it's either a 1 by 2, which is not possible. So therefore, these two options are actually out. Because number of rows on my left-hand side on my first matrix is actually 2 rows. So therefore, it's going to be 3 by 1 because ultimately, I can therefore get the last two options here. Now, when you multiply, take note the matrix I need to get. It's going to be, hope you all can see the trend, adult, senior citizen, children. I want to get the total cost in this case for Saturday and Sunday respectively. So how will you do it? Normally first, it's going to be, let's say I want to do for Saturday. How's it going to be like? Saturday, I hope you all agree, is going to be 48. Let me just write it in blue so that you all can understand. 48 times 40 plus 30 times 20 or 20 times 30 plus 26 times 18. Okay, similarly, if I were to write it out, it's going to be 40 this way, 30 and 18 to form my matrix. Because it is similar to saying 48 times 40, 20 times 30, 26 times 6, 18, which is the normal way of calculating, but we do it in matrices sometimes or even most of the time because a lot of information will be given and henceforth matrix it's actually more efficient to bring them together, bring the information together easier so that you all will be able to sort of get the information out easier. Okay, 2988. Okay, so henceforth this is 29884710. Okay, so again, matrices is to bring all the information together so that you are able to do multiple calculations like this. Instead of just doing one by one, you can do it one whole shot. So that's why we learn matrices, and we are going to see more of this in the long run. Okay, ultimately, this is going to be a little bit hard to understand, but more or less what I want to see is actually the progress. Okay, not really in terms of how you're doing, but if you all progress well, it's going to be a good sign for me. Okay, now, enough of me talking. Okay, one part, what does AB represent? Okay, what is AB? AB is in fact, okay, let me just write it out first. AB is going to be 43, 20, 26, okay, 75, 30, 45, and then we have 40, 30, 18. I know some of you got the answer already, but let me just write it out first before I actually make it better. What does AB actually represent? All right, right. Okay, launching the bubble launcher in 3, 2, 1, and let's go. All right, very good. Most of you all got the responses down. That's a good sign. It's a good sign over there. All right, most of you all nail it. Okay, I'll just wait for y'all. Don't worry about it. Okay, take note. One of you actually answered a particular option. Don't worry, I'll give you some time to think about it. Okay, so while you guys are doing it, let me just write down a hint over here. Okay, take note. This is Saturday. This is Sunday. And this one over here are the price of the tickets. Number of visitors. So number of visitors on Saturday, number of visitors on Sunday, and the price of the tickets are shown. So what will we have? Okay, last 1 second. Okay, I would say most of you have got it. That's a good sign. But let's see. Okay, for those who have not got it, let me just revise. Okay, now, what is the column that is written over there? The column over here is the price of the tickets as the matrix that you need to find out by yourself. Price of the tickets. So what we have over here. Now, if we try to picture, this is actually price of tickets times number of people. What is it going to be? It's going to be, in this case, based on the answer, total ticket sales. Right? So that's where most of you got it. Now, some of you actually answered number 3, but number 3 is not the answer because take note, now total number of visitors is actually summing my column. If I take this column, I sum all these entries, that's the total number of visitors. Okay, one way you can think about it is try to picture each of the entry. What does it mean? This is the adult. This is the adult price as well. Adult times adult, you're getting the revenue from adults on Saturday. And then you follow up from there. So it depends on question to questions and how we actually decipher the meaning from there. Alright? Okay, now, following this, let's follow up. Work example 2, again, a different matrix and how we represent. Represent the number of trays sold in a 3x2 matrix of 8. So following up, a farmer sells eggs in trays of 6 and 10, the number of trays of eggs. So there's a lot of information there. Try to actually digest the information from there first. Okay, so first, represent the number of eggs, trays of eggs sold in a 3x2 matrix. So in fact, what happens, look at the table first. If I ignore the words at the top and the bottom, is it a 3x2 matrix to start off with first? Is it gonna be a 3x2 matrix over here? It is, right? So let's write it up. So it's gonna be 3 rows, 12, 9, 20, 0, 0, 100. And this is my 3x2. Now, evaluate B. B is just matrix multiplying. So I have my A over here, 12, 9, 24, 0, 0, 100. This is multiplied by 6 and 8. Now, what do they represent? So take a look over here, 3x2. The other one is 2x1. So what are you going to get? You're going to get, again, follow the matrix multiply. This time I'll not do the steps. Follow the same notion. You should get the entries of, in this case, 1, 4, 4, 1, 4, 4, and 800. Okay, now, does anybody want to try? What do these entries represent, or what do these elements represent over here? I'll give you some time, write it down. What do these elements represent when I matrix multiply as such? Okay, to make sure you all understand. What do they actually represent before I launch the bubbles? Before I launch the next bubble question, which you know is coming up. Yep, in a way, it's more of the total. Okay, Denise give me an answer. Let me just double check. Yes, it's a total number of eggs, but be more specific. Let's say 144 is the total number of eggs. Very good. I'm looking for these 3 words. Okay, very nice over here. All right. So anybody else wants to give it a try? All right. Fiona has given me an answer, but it's not really the total number of trays. Take note. The trays over here represents the total number of trays is actually representing over here. Okay, number of trays sold. But take note, this is the number of trays. This is the number of eggs per trays. It will be like 6 and 8 is the number of eggs per tray. If I matrix multiply, it's not just the total number of trays. Okay, but you are getting it because this is correct total number of eggs sold. And to add on to Denise, you actually have to say this. You have to say these 3 words. That's right. And to on Monday, Tuesday, and Wednesday respectively. And for Jude to follow up, it's not the total number of trays. Take note. There's a reason why we multiply by 6 and 8. Because 12 and 9, if you take note, is the total, is the number of that particular tray. So what do I mean? 12 over here is 12 trays of 6. Okay, I have sold 12 trays of 6. 12 times 6, what does that give me? This gives me the total number of eggs because I have 12 trays. Each tray has how many eggs? 6 eggs. I want to find how many eggs. Total eggs, 12 times 6. So if we move the number of words of trace and replace with x, you get the notion. So you realize when we do matrix multiplication, it is a lot of, in this case, understanding the question. And when we matrix multiply, how do we actually get the entries instead of just blindly doing it? All right, so in this case, Jude, we're glad for a response, but let me bring it out to the floor. Let me initiate the feedback again to see whether you guys actually understand what I'm saying over here. Okay, okay, I'm seeing, I will just wait for the response here. Okay, so when we talk about matrix multiplication, we actually have to understand what we are actually doing when we matrix multiply. Very important. What we are actually doing. Okay, so if we actually don't matrix if we actually do the blind matrix multiplication, it's gonna be very hard. It's gonna be very hard to just, oh, I matrix multiply, but what does it mean? You have to read the question. From the matrix, what does it mean? You multiply. Oh, if you don't really understand matrix multiplication, you do it by the side. So in this case over here, 12 times 6, 9 times 8. Oh, what does it mean? Okay, this is 12. There are 12 number of trays of 6. Okay, so there are 12 trays, and how many? This one represents what? 6. Oh, 6 comes from where? Oh, there are 6 eggs. So 12 trays of 6. 12 times 6, total eggs is 72. So something like that. Okay, but I'm glad seeing the response. There's no rates over here, so that's an improvement. I'm glad to hear that. Okay, so let's see how you guys will fare with the next work to next bubble question, more work example. All right, okay, so what happens before you do this bubble question, I'll give you all a few seconds to take a screenshot of this because you will need it to answer one bubble question as well at your side. Okay, I'll give you some time before I launch the bubble launcher in 3, 2, 1. Okay, let's go. Let me launch it now and go. Okay, take note, it's a 3 by 1 matrix, so what should I have? Okay, 3 by 1. Take note, look at the entry carefully. Look at the entry carefully. Right, look at the entry carefully. White milk duck. Alright, let's see what we have. Okay. Okay, very good. Most of you all got it, but some of you all take note. Answer again, 2 and 4. 2 is not a 3 by 1, it's 1 by 3, so 2 and 4 is out. Now take note over here, when we talk about respective prices in 3 times 1 matrix X, first we got to visualize, okay? When we talk about a matrix, 3 by 1 matrix, the first one, our matrix is going to be here already. This is our first matrix. So the mixed matrix, what we do over here is we actually just put it down. 30 times what? Price. The other one times what? Milk times price. Last one is going to be dark times the price of the dark. I mean dark chocolate, not this dark, but the dark chocolate. Alright? So that's where how we visualize accordingly. Okay, so usually the matrix, what happens? We actually write it down straight. So this is going to be hard because some of you all thought, it's a 4 by 3. No, but it's a 3 by 1. So how do we actually write it down? So again, that's where the understanding comes in. It's a little bit hard for me to grasp. So if there is any help, then neither after the end of the lesson, not after at the end of the lesson, just let me know during the Q&A. Alright, so now we know part 1 is the answer based on the intuition of multiply matrices. Let's move on and see this. Now we know X is in this case what we have. Three, 3.5, and 4. Okay, how do we find out? Again, launching the bubble launcher, 1 minute. 3, 2, 1. Okay, 1 minute might be too short, so I'll give you a head start of 30 seconds to give you the shot first before I launch the bubble launcher. I'll give you a head start of 30 seconds first while I drink some water. Okay, now I'm going to launch the bubble launcher in 3, 2, 1, let's go. All right, that's good. Good to see. Okay, this is actually just a recap of your matrix multiplication. 34, 18, 38, 42, 30, 36, 40, 22. And with a 3, 5, 3.5, and 4. Matrix multiply, just make sure you get the correct entries and you should be fine. Alright, last 18 seconds for those who have yet to matrix multiply. Quickly, nearly down. Okay, last 8 seconds. Okay, last 5. Okay, let's see. Okay, some of you all actually got it down at the end, but I understand matrix multiplication can be a little bit tough. So let's see how we do it. Okay, take note when we matrix multiply, it's always row by column. Okay, one thing to take note over here. What is the order of the matrix? If you recall my previous lesson, my habit is this. Before I matrix multiply, ask yourself, what is the order of the matrix that I am going to get after I matrix multiply? Which is 3 by 3, 3 by 1. So in this case, we know our n is going to be 3 by 1. Hence, these two are up. Second thing, because this is MCQ, but of course in exams, it will take longer. So therefore, MCQ, what you do, you see the first entry over here, which is the relative one. If you matrix multiply, you should get this. Okay, where the first entry is respectively 30 times 3 plus 24 times 3.5 plus 18 times 4. And then you realize the rest of the entries will be there. You can check it when you view the recording again or at your own discretion when you revisit the video. Most important. Alright, now, okay, matrix multiply. Look at this matrix that we have. Remember the screenshot I asked you to take. What does the elements of y represent? So remember what we have over here. What is the elements of y? Take note, y is in this case the 246, 381, 336. Okay, the previous screenshot will help you. That's where it happens. Launching the bubble launcher in 3. Sorry, it's not 3. Sorry for that. It's 3, 2, 1. And let's go. Take note. Look at the... Again, take note. Look at what is part A showing. Some of you are falling into the trap. Okay, most of you skip the 2 options for now. I'll just wait for the timer to run. Revenue is actually the amount of money that the person sort of gets when he sells stuff. So that's revenue for you. Okay, I'll just wait for 10 more seconds. Okay, some of you are falling into the trap. Last 8 seconds. Okay, seems like I need to go through this one. So let's view back. If we were to actually go back to my bubble question 4. So now if you take a look, when I matrix multiply, some of you fell into the trap and answer option number 3. Total revenue for white milk and dark chocolates respectively. But realize what I'm doing here. When I multiply 30 with 3, that's the revenue for white chocolates on Friday. 24 times 35, that's the revenue for the milk chocolates on Friday. 18 times 4, that's the revenue for chocolates for dark chocolates on a Friday. So when I actually multiply them, I'm getting the row for Friday. So you realize I keep emphasizing the words Friday. What does it mean? The first row actually represents for Friday. So that's why the screenshot is very important. And henceforth, number 1 is the answer from there. Friday, Saturday, Sunday, respectively, equal to matrix multiply. Alright, I hope you guys got it from there. Make sure you understand. If it's not sure, there's a Q&A session at the end. Just make sure that you guys understand from there. Okay, now we just have actually one more example before we actually call it a day for today. Right? So is it one more? Yes, one more. Yes, we actually have one more before we call it a day for today. So let's see how it goes by. Now, this looks like a hardest question of all. Why would we say? Because what happens, this question doesn't really guide you at all. In fact, we can do it normally, but it's going to take too long. So what can this question suggest? Oh, using matrix multiplication, find the total amount of collected by all three vending machines. Now, what most of y'all will do, okay? Most of y'all will actually take 80 times 190 plus 25 times 190, or you might actually just sum all of this up and multiply, sum of all this up and multiply, sum of this up and multiply, sum of this up and multiply. But that might be a bit confusing. It might be easier, but because this table is a little bit big, you might get entries mixed up. Some of it 80, 190, then suddenly your eye switch to 68 plus times 190, or somehow or other 42 times 120 out of nowhere. Okay, so and of course, because the question says matrix multiplication, so therefore you have to use it. Okay, yep, Denise, that's actually correct. In fact, okay, for the first part, so how do we matrix multiply? First one, if you see, prices over here, it's one side. We don't want to care about the prices. Prices, it's another part. What I want to see is the total number. If you want to see from the concept that we have, we want to see what's the total number of stuff that we're looking for. So we write that down, and following up nicely from Denise, the prices are actually mentioned in the column as such. So first one is actually a cheat code. What you can see, the total number of items there, we actually write it out as such. So 25, 68, 57, 15, 90, 42, 81, 43. And then how do we know that's the column? First check. This is 3 by 4. Second check. That is going to be, this column works because it's going to be just multiplying that. 4 by 1. And what is the matrix you're going to get? I'll just let y'all do the matrix multiplication doing this way. Okay, matrix multiply, you'll get these entries over here. I'll let y'all do the check. If you have time, you can do it now, or let me just write the entries. Or in this case, you can actually do it when you review the recording at your own side. Right, now, total amount collected by all three vending machines. Before I carry on in terms of matrix multiplication, how do you think you guys will do it to find the total amount collected? If I talk about money, what is the total amount collected over here? How will you all do it if I didn't say matrix? Write your answers down. I'll give you some time to think about it. Write your answers down. How will you all do it if I didn't say matrix multiply? Okay, think about it. This is the revenue for vending machine A, vending machine B, vending machine C. So ideally, what y'all will do, y'all will actually, okay, so this is not the working. What do you actually do? I'll give you some time. Let me just drink some water over here. Okay, I think you guys are getting it. So ideally, what y'all will do, all of you will just add up all these things over here, right? Y'all will just add this up. But take note, question says matrix multiply. So how do I form this in a matrix? Now remember, matrix multiply, there are always something multiplied by something. Something multiplied by something, something multiplied by something. So therefore, can I actually say that this entry is actually 1 times this, and 1 times this particular way of multiplying my stuff? After all, and how would I represent this way of multiplying matrices? Now overall, I need 1 entry. Take note, this entry over here, do you agree? Ultimately, when I multiply, I only get 1 answer. So it should be a 1 by 1 matrix I'm getting. Right? Making sense? Now, over here is actually a 3 by 1 matrix over here already. So let me write down my 3 by 1 matrix, which is 3, 6, 0, 2 for 1.6 4 to 0.3. Now, if this is a 1 by 1, this is a 3 by 1. What is the matrix? What's the order of the matrix over here? I should multiply by this to give me this. Write down the response. What is the order of the matrix over here that I should multiply with this to give me this? I'll give you some time. What is the order? Very good, Denise. That's actually the answer. I'll give it down to the rest. What is the order of the matrix? Okay, so you realize, okay, most of you have gotten it. Very good. So in this case, this is a 1 by 3. Now, how do I form this 1 by 3? Look at how you multiply. 360, 246, 241.6, 420.3 is written there already. So what are the numbers left? 1, 1, 1. How do I put it in the 1 by 3 matrix? How will you picture as a multiply? This, and this. Because row by column. Multiply, it will give you the number 1022.4. Right, so this is how you get it from there. Okay, understand this a little bit hard while I do this because they say using matrix multiplication. So this will not work if they just talk about matrix multiplication. But this step is still important because it's sort of like the intuition to how you get the matrix over here. All right, so again, let me initiate the feedback to actually see how you guys understand this. If not, what happens? There's a Q&A later for this type of questions. Okay, don't worry about it. Understand it's a little bit tough. So at the end, there's a Q&A. If you want me to reinforce this work example, just let me know. Okay, very nice. I'm seeing a little bit of, okay, I am pleasantly surprised that most of you are at the yellow and green part. That's a good thing. There's a little on the red part, so don't worry. For those who are on the red, just let me know who you are. Don't worry about it. Okay, if you're shy, I'll be more than happy to answer your queries during the Q&A. All right. Okay, very nice. Okay, so most of you are the yellow and green. That's a good start. So let's see how you all perform by yourselves, step by step, for the bubble questions. Okay, read this question very carefully. I already say myself already. I already give you a hint. Read this question very carefully. Launching the bubble launcher in 3, 2, 1, and let's go. Okay, there's a reason why I give. Some of y'all may feel, why do I give 1 minute for this when it seems rather okay? Look at this question very carefully. Again, answer says column matrix. Take note. Some of you are falling into a trap. Read the question carefully. Question gives what? What do the question want? Keywords, keywords. Look at the keywords very carefully. Counting down last 5, 4, 3, 2, 1. Time's up. Okay, some of you all just want to copy the column matrix, but take note, this is not so simple as copying. It's a little deviation. Table shows monthly. They want annually. 1 month, 1 year has 12 months. So we need to multiply by 12 to the answer in number 1. That is why my answer is 4 instead of 1. Alright, take note. Alright, okay, take note from there. Now, next up. Denise, that's actually a very good thing. No, I cannot exactly see who gave the feedback. So what I have, when you all have the feedback to me, there are only 3 things I can see. I only can see red, yellow, and green and the percentages. So don't worry if you're afraid, okay, who exactly gave me the feedback? No. There's no idea, no notion of me not knowing who gave the feedback. There's only the overall thing I can see. Okay, so if you're shy and say, oh, I am a bit shy in terms of understanding, I don't want to have the name there. Okay, your name is not there. It's just red, yellow, green. Red means you don't understand at all. Yellow means half. Green means you totally understand. Right, no problem, Denise. Let me follow up with bubble question number 8. Okay, this one 1 minute. Okay, it shouldn't take 1 minute, but just calculate in 3, 2, 1, and let's go. Okay, wait. Wait. Give me a while. Let's go. Okay, take note. Just subtracting. Take note. Don't subtract wrongly. It's 20, 30, and 50. So 12. Remember, the first one is achieved in bubble question 7. So doing the subtraction. So it's going to be 20, 30, and 50. Alright, from here it's just a normal calculations, okay? Shouldn't be too unfamiliar. Last 13 seconds. Okay, last 5. Alright, okay, some of y'all managed to get it down, but take note, it is the calculation errors. So be careful, just take note. Just do the subtraction. So subtract the correct elements, 480 minus 20, 460, 930, and 2950 respectively. Okay, some of you answer number 3 because the last entry is not correct. Okay, it's minus 50, not minus 100. Okay, so take note. Okay, next up, following up with the understanding. How do we actually explain what you have calculated just now? Okay, part B, take note. What you have calculated just now in part B. What does it represent? Okay, so take note. This is the annual expense. This is the rebates. What does it represent? Launching the bubble launcher again in 3, 2, 1, and let's go. Rebate is actually like discount, something similar to discount. So example, let's say you go to McDonald's and you decide to it's something like discount, but it's not really discount. But I can give you an example that is similar to it. So example, you go McDonald's, you want to buy an ice cream cone. So an ice cream cone depends on outlets, but I think it's $1. So suppose let's say you get a 20-cent discount, that's like a rebate over here. Something like that, but it's not like that. So I'm giving an analogy. Okay? Yes. Okay, last 20 seconds. Okay, some of you all got it. That's a good sign. If some of you all got it. Okay, last 10 seconds. Last 5, 4, 3, 2, 1. Okay, most of you all got it. Let me see over here. So what happens is, okay, now you realize how does this work. Annual expense for each of the mode of transports minus the rebates. So that's why it's number 4. Okay, some of you actually say 3 or 1. Take note, 3 is not total. I'm not adding them up. Lastly, number 1 is not before rebates. If it's before rebates, this will not be here. Right, so take note. Okay, now, last part. Using matrix multiplication, find the matrix representing. So you realize all the answers are the same. So in fact, what happens, this should only take 30 seconds because all the answers are the same. But which one is the correct one? Okay, launching the bubble launcher in 3, in 2, in 1, and let's go. In fact, what happens is I'll show you the actual working, but this shouldn't take too long. Over here. Okay, this shouldn't actually take 1 minute, but I give you 1 minute for those who actually want to try the matrix multiplication to make sure that the number you are getting is correct. Take note, I'm looking for the matrix representing. Look at the question. I'm looking for the matrix representing. Okay, last 20 seconds. Okay, So don't worry if you're wondering whether this lesson will extend for very long. Nope. Okay, this is actually a last power question. After I go through this, will be end of the lesson already. Alright? So don't worry about it. Okay, last 5 seconds. Okay, very nice. Okay, some of you have actually gotten it. Okay, some of you actually answer it very fast because you see the word matrix. So what is a matrix? Matrix has no symbols, no nothing, just a bracket. Take note, brackets important, so 3 and 4. And it doesn't have additional symbol. So it should be number 3 because this is wrong because it has this symbol here. Take note, it should not have an additional symbol. This has an additional symbol, so that's why the answer is not correct. Now, how do I get 434? Take note, if you refer to my work example 1, you realize if I were to take this 111, if you refer to work example 3, you can refer to that to know how I get 111. Multiply by, if you refer to my matrix over here, 460, 930, and 2950. I'm gonna write this matrix down. Okay, multiply all this, you're gonna get, again, it's similar notion. This row multiplied by this column is still going to be 1 multiplied by 460, 1 multiplied by 930, and 1 multiplied by 2950. Okay, multiply all this. It's the same notion as how you multiply when you do it normally. Just that, let's say if they want matrix multiplication, this is how you do it, and you will get the answer 4340. Right, that's the notion. If you're still unsure, there's a Q&A. I'll explain it more. Otherwise, refer to the recording for work example 3. Alright, so with that, that's actually all for today. So that's what we have learned. And in fact, a lot of it is recap. Main thing over here is the real world context. Alright, so that's it for me today. Ultimately, what happens over here, I actually don't really want to see how perfect you guys are, but more of the progress that I'm looking for. Alright, more of the progress that I'm looking for. Okay, but more or less along the way, you guys are doing good job based on the responses I have. Give yourself a pat on the back and say well done to all of you. Alright, now again, there's a Q&A session later. So for those who are actually interested to stay, feel free to stay with me for the Q&A. Otherwise, take care, stay safe. I'll see you all then. Alright, take care. Bye bye. See you all next week. Bye bye.